Okay, let's look at question 4C. At time t equals 2, train A's position is 300 meters east of the origin station, and the train is moving to the east. Write an expression involving an integral that gives the position of the train A in meters from the origin station at the time t equals 12. Use trapezoidal sum from 3 sub-intervals indicated by the table to approximate the position of the train at time 12. Okay, so what am I doing here? Well, it tells us that we start at a position of S equals T, which is going to be 300, right? And then it says it wants to know how far it moves. So how far it moves, remember we said if we integrate velocity, we get position. So we're going to go from 2 to 12 of Vt dt. And we need to include the original position, which is, I put t here, but I really should have probably put 2. Alright? Okay. So this becomes 2 plus, I'm sorry, not 2. This becomes 300 plus the integral from 2 to 12 of Vt dt. Okay, I think they call it VA dt, so I'll call it VA dt. Alright, so now what we have to do is we have to figure out using trapezoidal sums. Well, trapezoid, remember, is 1/2 base 1 plus base 2 times the height. So we're going to start from, we're going 2 to 12. So 2 to 12 means I'm going to take these values, right? The difference between these two values, which is 3. This is going to be the height. And then we're going to add this and this. Okay? So let me be clear about this. What I'm going to say is that, like, if I draw this picture, right, we're saying at 2, it's at 100, right, and then at 5, it's 40, right. I'm just going to draw this piece here. This is my trapezoid. What I'm doing is I'm taking the difference of this right here, which is 5 minus 2. So this distance is 3. I'm going to label this as my height. Okay. So I know that height you're thinking from bottom to top, but we can, if I turn the picture, this can be, we can label this as the height. And the reason why I want that is because this value and this value are different. So this height is obviously going to be 100 because it goes to 100, and this height is 40, right? And then instead of calling it height, I'm going to call it the base, right? These are my bases. So my base 1 is 100, my base 2 is 40. Okay? And then, so what am I actually doing? I'm just taking the difference here, which is 3. My bases are this and this, which is 100 plus 40, and then all of that I'm dividing by 2. Okay? And I just keep repeating it. I think this is the easiest way of doing it. It's also the fastest way of doing it, so we're just going to do it that way. So your next one's going to be, the difference here is 3. So it would be 3, base 1 is 40, base 2 is negative 120, divided by 2. And we just keep adding across. Okay? This actually, when we draw this, it actually becomes a little tricky. I'm just going to avoid that altogether. I just would follow this formula here. Okay, so we'll go back here. We'll rewrite what we just did. We said 1/2 3 times the quantity 40, 100 plus 40. So it would be 3 times 100 plus 40 divided by 2 plus 3 40 plus negative 120 divided by 2 plus 3 negative 120 plus, oh look, I made a mistake here. 12 to 8 is 4 actually, so this should have been 4 negative 120, and I didn't see, I think it's negative 150. Yeah, negative 150. divided by 2. So we just have to solve that, and that's going to give me my answer. So it's going to be 3 times 140 over 2 plus 3 times, what is that, negative 80 over 2 plus 4 times negative 270 over 2, right? And then at the end we're going to have to add the 300, right? So let's clean this up. This becomes 70, so that's 210. This becomes negative 43, negative 120. This becomes negative 540. So if we clean this up, this is going to give me, these two are going to give me 90 plus negative 540, which is negative 450. So if we take the 300 from originally up here, this 300 plus the negative 450, we get negative 150. And that's our position, right? So negative 150, I guess, meters. Meters. Okay. So again, just to summarize, what did I do? It said the position in the beginning of the problem. It tells me that the position at 2 is 300 meters. So I started with S of 2, which is 300. Okay. This function given, right, is a function of velocity. So if I integrate the function of velocity, I will get position. So this is why we integrate here and we integrate here. Because this is a chart question, when we integrate we use the appropriate method, this case trapezoidal sums, simplify them, trapezoidal sums, and add them together, add the original 300 plus the trapezoidal sum, which is negative 450, I get negative 150. Okay, hopefully that makes sense, and I'll see you all in the next video.